Hey, hi everyone. This is Sivasis. I am an expert in microservices and cloud performance optimization for fintech solutions. Welcome to Fintech Fast Bytes. This is a series of 8 short videos where we will discuss a real enterprise problem and its solution. On this occasion, I would like to thank AAITP to give me this opportunity to showcase my expertise in this forum. So, without wasting much time, let's start with our first topic. Your API gateway is the new monolith. So, we know that we have broken our micro means our monolith applications into microservices slowly from last couple of years. But now we see that gateway has become a new monolith. So, let's talk about how that happened. I mean, how to fix it before our enterprise or the fintech system slows down in production environment. So we'll talk each aspect of it and we try to solve the problem. If you see my experience, I have an experience in fintech system where in various modules, you can say where payments or account services or our internal planning and forecasting tools. So in many of them, we go for microservices architecture, but we end up routing all our traffics, right, to the gateway. So what the gateway ends up in doing is all the logics like TLS, the authentication, the feature flags, sometimes logging, caching, and even some business decisions goes into the gateway logic. That's where it grows as a monolith. Sometimes it becomes as a control plane where everything gets controlled in one gateway. Every request waits for its own, for this gate to solve the problem. So we just moved from one monolith to another. So let me talk about a case study recently which I faced in my application and one of the scenario and one of the product where what happened is our gateway became a centralized gateway serving 100 plus microservices. So what happened when a customer checked out a transaction, 5 chain calls went through all through the same gateway, right? So the service became slow, but it was not the backend application. Now, how did we figure out what was the problem? When we investigated, we found that when each call was investigated, we saw it was logged, it was getting authenticated. So our legacy feature flag, there was a feature flag as well. That code also was integrated in the gateway. So under peak traffic, what happened? The latency spiked to 600 milliseconds per API. And then that's it. So our SLA failed, alerts were fired, and the rollback was needed. So that's how tough it has gone. So what went wrong this time, right? We treated the gateway like a central smart hub, which we should not, but we did. And we routed the internal calls to the same gateway as the public ones as well. We also found there are business logic present in the gateway layer. And the most worst part was when it breaks, we always blame to the downstream system or the services until we trace and find the truth that the gateway has choked all our data. That's where it became slow. Now, how do we fix these patterns without having much code change or getting deeper into a time frame where we could not meet our timelines? Three approaches we can take. One we can say is the domain aligned approach. And yeah, it's called as a domain aligned gateway. So split service by domain. Yeah, very simple, right? Second one is edge versus internal gateways. So external for TLS or authorization, internal for routing. So we can easily separate that. Third one is we can go for the backend for front end architecture. So backend for front end is nothing but we can tailor our APIs to the front end clients. We know that mobile, web, all are different applications. They might be doing the same purpose, but they are different. So different clients need different payloads. So we don't want to overfetch or underperform as well, right? So these are the few fixes we try to put to solve this gateway problem. However, gateway design changes was not enough as well. We also have to correct some boundaries. One of such thing is event storming. There's nothing but event-based calls help us to solve this problem as well. So instead of saying, let's make a service for user data, we asked ourselves, what real-world event starts this flow? What decision does this service make? So these are the kind of questions we can ask ourselves. For example, in one case, when a loan is approved, so I will give an example of a fintech world. When a loan is approved, an event gets triggered for funds disbursement, right? So in that case, notifications are sent to the compliance and to the analytics. So all three services wait for that notification. So here we suddenly found out that each one can do its own job rather than waiting for each other or one call to finish, then we start the next call. So this was a very good example of event-driven architecture where we can easily split our API calls into event-based. Now, what happened with these changes? One is the architectural pattern changes. Second is the event-based changes. With these two, we saw a significant drop, that is around 30 to 35% drop in the internal request latency. That is one. Second, we saw the transactions were completed 20% faster and customer confirmations messages were going 20% faster. Right? The retry logic were totally cut into half. And the best thing we'll know that we didn't write or rewrite a single service. Right? That is the power of architecture at the edge, not just at the code level of the microservices. So to be very brief, what we have to avoid. So when we are building a gateway, we should always avoid putting the business logic in the gateway. Whenever we are trying to put some business logic in the gateway, we should stop there. The second one is we should not ignore, right, the matrices or tracing. We should not ignore matrices and tracing. And we should not treat all APIs the same. Mobile is not equal to web, is not equal to internal apps. All are different APIs. We should think about it. And also we try to version the APIs. Versioning the API is very important. So globally breaking clients is a guaranteed 5-star. So there is a saying. So if your API gateway has turned into a catch-all mess, so we should always take a step back, split our traffic wisely, and redesign for resilience, not just for access, I can say. All right. So what is the takeaway for our brief discussion today? Split the gateways by domain. Number two, separate the internal and external logic. And number three, design event-driven microservices as possible. So with this very conclusion and takeaway, I would like to end my session here. And I want all of you to share your API gateway challenges in the comments, or you can tag your colleague who has been involved in gateway building, and follow me for weekly fintech architecture insights. Until next time, for second video, second problem, second solution. Thanks a lot.